So I'm mm, all right. So welcome everybody. Let me just get my notes pulled up here. Um, I'm Allie Ribby. Some of you all have met me. Some of you, if you're earlier on in your coursework, you have not met me yet, but you will. I'm the employer relations manager for CodeU. And I'm super excited to host tonight. Before we get to Jess, I just have a few things that I want to go through. Next week, we actually have Dr. Brent Seals is going to be presenting on unlocking ancient secrets with AI, which sounds like something that would be on the History Channel. Super exciting. So that'll be fun. And then, we're a little bit slower when it comes to events right now with the holidays, but we should have one or two events coming in the new year, in February and in March. So keep an eye on Slack and the newsletters, Tech Careers newsletters, things like that for that information. For modular folks, if you are attending as part of your career readiness requirement, definitely remember to fill out the form in your, not Google Classroom, in your open class to get credit for attending. Obviously, if you can keep yourself muted through the presentation, we're going to be we'll have time for questions at the end. Feel free to drop questions in the chat as you have them, and we'll go through them then. But yeah, so we're joined tonight by Jes Chapman, who's going to present on how to choose the best Azure database. Jes works at Microsoft and has been there for 13 years in various roles-ish. Is that right, Jes?
Yeah, so I was on MVP for about 5 years before I fully joined about almost 9 years ago. Yeah, so it's been a long time.
Yeah, so I initially saw Jes speak at the Rocket Women Conference in October on a panel with a bunch of other awesome women. And she graciously agreed after I LinkedIn stalked her to come and talk to you guys. So if you can't stay for the whole call, this is going to be available on our YouTube channel for you to check out if you miss any of it, and for those who couldn't attend. But I'll turn it over to Jes.
Great. Thanks, Allie. So hi, everyone. Jes Chapman. I live right here in Louisville, and I work for Microsoft. So, I should probably share my slides. I'm used to using Microsoft Teams because I work for Microsoft. So here I am like poking around in Google Meet trying to find the right button. And
I didn't even think about that when you were like, yeah, we use
okay.
Teams at Microsoft. I was like, oh, right, because you make it. I forgot.
Yeah, so what I do at Microsoft, my job title is Cloud Solution Architect with a focus on data and AI. Now, what does that mean? So I am one of the customer-facing people at Microsoft. I don't write code for our products. I'm not in marketing. After customers agree to, put projects, applications, databases, files, AI, whatever it is, into Azure, I am one of the architects that, number one, helps them make sure that everything is designed correctly. And by that, I mean that they are following Microsoft and Azure best practices for security, first and foremost, networking, performance, and that they are, following all of their company's policies, best practices, et cetera. I can help them migrate data into Azure. I might help them, after things are up and running, execute performance tests, check on security things, help them scale up, help them scale out, a variety of different things. Again, my focus is on, so while Azure is it's a huge cloud, it contains tons of services. My tech background has always been in data and databases. So I started working with Microsoft's SQL Server Reporting Services product 2005, back in about 2008, when I was still last couple semesters of tech school, had a help desk job, learned to write SQL, started writing reports. So I've been working with SQL Server and SQL databases for going on 20 years now. That's a long time, and have since branched out into other databases. You may have heard of Postgres, right? An open source product. You might have heard of MySQL. We have NoSQL databases as well, like Cosmos DB. And so that's what I'm going to be focusing on today, just kind of talking through different database options that are available, specific in Microsoft Azure, but a lot of these are available in other flavors. You can download them and use them locally or in a data center. You can get them in other clouds. And I mostly want to talk about like what types of apps and websites they will work best for, what kind of use cases, like if you're looking at gaming or retail or a logistics system, like what kind of data sources and databases work best with that. I love questions. Please feel free to drop questions in chat. I have that open on my second monitor. And yes, I will take questions at the end. And finally, my About Me slide. So again, I've said all of this, but please do connect with me on LinkedIn. Please search for Jes Chapman. I realize my link still says Jes Schultz, so I have not updated that since I got married last year. I will also share these slides with Allie. Allie, do we have a way to send out like the PowerPoint slides or the PDF to the team so they can get all the links?
Definitely. I can include it in the announcements
Okay.
in the Slack channel. Yeah, and pin it.
Great.
Oh, wow.
Great. And then, yeah, so I'll send a link. In addition to my LinkedIn, I also have a GitHub account. So if you have a GitHub account, if you want to go and look through, I have some different SQL related projects, some container things, and also presentations, Azure SQL, so tons of stuff out there. So yes, again, please connect with me on LinkedIn. I post there quite a bit and always eager to help people in the next step in their career as well. So let's get into it. Things I'm going to talk about today. When it comes to the cloud, I'm going to talk a little bit about infrastructure as a service versus platform as a service. We call it IaaS versus PaaS. Because in this presentation, I want to focus on the PaaS database offerings, so platform as a service. I'll talk about kind of what makes them unique and what makes them a platform, like what makes them a managed service, what part of the service is Azure taking care of for you, so you can learn a little bit about why people would move into those databases in the cloud. So IaaS versus PaaS. IaaS is infrastructure as a server. This is where you, as a customer, are basically renting infrastructure from a cloud provider. So this could be a virtual machine with its CPUs and memory, could be storage, could be operating system, anything along those lines. IaaS gives you typically the most control in that you just pick the virtual machine type. What type of processor you want, how much memory you want, how fast do you want your storage? Do you want to run Linux or Windows? What software do you want to install on it? But that also comes with some trade-offs in terms of management. So with infrastructure, you have to do operating system patches. You have to do application patches. You need to control all of the networking. On the other hand, all cloud providers also offer PaaS or platform as a service offerings. This is where you kind of rent ready-to-use software or platforms. So when I think about this in terms of databases, right? In Azure, you can rent SQL database. In AWS, you can rent RDS, relational database services. In Google, you could rent BigQuery. These are all data PaaS offerings. So in this offering, there's less control in that you're not going to get to pick necessarily the operating system version. You might not have access to specifically know what version of Intel Ice Lake that CPU might be running in the hardware. You don't know all of the networking details. On the other hand, You don't have to manage any of that. Patches put in place for you, security updates put in place for you, operating system updates, database updates, all of that put in for you. So there are, as all things in IT and computing, there are trade-offs, and I'm going to talk a little bit about those today. When learning about IaaS versus PaaS, I like to compare the cloud services to pizza. We all love pizza, I hope. But just as a quick kind of walkthrough, right? So when you order pizza, from most intense to least intense, right? Maybe you're prepared to do all of the work at home. You go to the store, you buy all the ingredients, you roll out the dough, you start up the oven, you set the table, you cook the pizza, you put it down, you cut it. If you want to do a little less work, but still and pay, if you want to do a little less work and pay a little bit more money, you might do a take and bake, right? Where a company makes the pizza, those things in green, but you still bring it home, provide the electricity for the oven, take the time to cook it, put it on your table, have some soda to go with it. So you don't have quite that much time though, right? So again, you give up a little bit of money, but in terms of effort, you have someone deliver your pizza. So now the company has put together the pizza. They have heated it up for you. They're even going to put it in a nice, warm, or one of those insulated bags and bring it to your house. You are still going to go ahead and set the table. You're going to get out your drinks. You're going to cut it up. You're going to give it to the family. And what if that's still too much? You want to go and dine out. You don't even have time to wait for someone to deliver it. You just want to get pizza on the way home from a soccer game or work. So this is dining out. Most convenient for you. You don't have to cook anything. You don't even have to get plates out of the cabinet. You don't have to wash any dishes after. And it comes at probably the highest cost out of all of these options. This can be directly correlated to having services in the cloud. So the way that I compare this is, right, that making a pizza at home is equivalent to running an application on premises. Your company has its own data center or rents data center, and you build everything from scratch. However, if you want to, again, take away some of the management and take on a little bit more cost, the equivalent of take and bake in the cloud is going to be what I was just talking about there with infrastructure as a service, or IaaS. So here, some of the things are managed by the cloud vendor, and other things are managed by you, the customer. And if you want to do even less management, I talked about PaaS, or platform as a service. So in this case, the vendor, again, takes care of more things, not just the infrastructure of the pizza dough and the toppings, but also providing the energy, the heat, the cooking of it. And last but not least, you may also hear of SaaS, right? Software as a service. And this is a model that I would equate to dining out for pizza. In this case, I don't just roll my own database in SQL. I might, for example, go with CockroachDB, right? That's a completely SaaS, NoSQL database option that's out there. So that is how I would like you to think about kind of these different cloud models. And we are going to be focused on the platform as a service offering. I don't need to talk about this at length. Yeah, I put a lot of clicks in there. I haven't gone through that too much. All right, so now that we know it, we're going to be talking about that platform as a service, right? Which is kind of the equivalent of getting a pizza delivered to your home. Let's talk about what kinds of different data stores you might want to work with in the cloud. So there are going to be three primary data types that we're going to talk about tonight, because I'm talking about transactional databases. We have OLTP or transactional data. On top of that, we could also talk about analytical or OLAP databases, data warehouses, the Databricks of the world, the Snowflake, that sort of thing. That's another hour discussion. Maybe Allie will invite me back for another one of those later in the year. But for now, we're going to talk about just how do you handle your website data, your order entry data, your logistics data in these relational data stores, in these transactional data stores. And there are really three primary types. Number one being relational data, right? And this is where you have really highly structured data. You have a parent and its children, or essentially a primary key and its foreign key relationships, constraints, that sort of thing. When I think about a really common example of a relational database, I think about any sort of order entry system. You're going to have these different entities, like you have a customer who's placing an order. That order is for items that come from suppliers. The order is for a very specific number of items that cost a definitive amount. They are done on certain dates. And all of this is related, right? One customer could order 1 or 10 products. 10 of those products could come from one supplier, or they could come from 10 different suppliers. The products could be 7 different colors, but it's really highly structured. That's relational databases. Sometimes you have data and you don't want it to be that tied up into tables with their rows and their columns. Not everything has the same data type. When I think about this in relation to kind of that whole order entry system, I think about a catalog. Some of us might remember getting like the JCPenney or the Sears catalogs, right? This time of year. Toys R Us catalogs. Who didn't love that, right? And think about all of the hundreds, if not thousands of items that are in a catalog. And think about all of the different product information that those suppliers need to keep track of for each item. You might have a piece of clothing like the shirt that I'm wearing, which has a color and a size. Is it fitted or is it not fitted? Is it short sleeve or is it long sleeve? That kind of thing. On the other hand, my phone does not have size information other than inches high, inches wide, inches deep. It has an amount of memory. It has a type of camera. Those are objects that are not at all similar to the shirt, which is also completely different than this mug that I'm holding, which is a certain height and holds certain ounces of water and has a color. So there's some common things there. But if you've ever tried to design a relational database, you know that kind of data is not well suited for one table, like just products with the same columns for everything. So we call some of this data non-relational or NoSQL. Frequently, we store this data with what we call a flexible schema. It's in a document format. So JSON, we can assign common properties to everything, color, but we can also have varying properties across things, and it's not as structured. So those are non-relational, or sometimes referred to as NoSQL databases. And then the third type of kind of transactional data store you might see in a cloud is an in-memory data store. And these are often used for really low latency, really high throughput data storage. So when you go into the Azure portal, I just took this screenshot today to make sure we're up to the latest and greatest. And you click on this little hamburger up here to look at all the services, and you go to databases. There's a lot there, right? So if you're coming in to design an application, or you're designing an application and you're wondering what database to choose, you might be going, gosh, what do I use? So that's what I'm going to help you go through it. Why are there 4 different SQL databases here? What is Cosmos DB? Where does Postgres fall into it? So we're going to talk about some of the most commonly used Azure databases what type of data store they are, and again, kind of what applications and styles they're used for. So for relational databases, we'll talk about the SQL family of products. So Microsoft's SQL Server, SQL Database, SQL Managed Instance, they're kind of one database engine that just has a few different options. We'll talk about MySQL in Azure, and we'll talk about Postgres in Azure. They're probably the three most common relational databases for apps and websites, not counting like SQLite for mobile apps, because that's a totally different style of infrastructure. For non-relational, I'm going to talk about Microsoft's Azure Cosmos DB, used a lot in Azure. It has all these different APIs in it. I'll give you some examples of what they do, what they're used for. And then for an in-memory or caching service, we'll talk about Redis. Caching services usually sit between the application and then the main relational or non-relational database to serve up some data really fast. All right, so let's talk through what some of those relational databases are and what sets them apart from each other. So we're going to start with the Azure SQL family of products, which I liken to kind of the Formula One cars. These are going to be the most expensive that are out there, right? This is a product that was built and developed by Microsoft over the last 30 years. When you're using it, you're not just paying for necessarily the compute that's underneath it and the storage, but you are also using their licensing for the product. What you get with that, though, is a lot of really advanced enterprise level features. So this is why I call it a Formula One car. Not only do you get the fastest, prettiest car, what has a lot of logos on it and a very fancy name, but it also comes with the whole pit crew, right? It comes with a team of drivers. It comes with coaches. It comes with support. So Azure SQL is that, you know, in Microsoft's cloud, it's Microsoft's database engine. So it has all of the bells, all of the whistles, all of the support. One thing that I do want to call out that kind of sets this apart from the other database systems is it has what's called an evergreen database engine. So with most software, including databases, there are, you know, major versions that are released every few years, and then minor versions maybe every couple months, patches, that sort of thing. Even for Microsoft's on-prem SQL Server product, you had SQL 2017, SQL 2019, SQL 2022, and you'd still have to do major version upgrades. They usually come with new features. Before I worked at Microsoft, I was a database administrator, had to do many database upgrades over the years, lots of testing required, very time consuming. Make sure all the apps can connect, make sure there's no regressions in performance. With the database in the cloud, specifically SQL Server in the cloud, it's become an evergreen database engine where all of those little, not little, I never call security patches little, but security patches, updates. So Windows updates, SQL Server updates, all of that except for like the actual database engine with performance changed itself is done in the background. So a database, one of the benefits of that is whereas most software has like an out of support date, Azure SQL never does. No version upgrades ever need to happen. As a former DBA, I can say, I love that. And again, because it's that kind of Formula One of cars, it is a go-to database for enterprises, big companies that need really big security features like data encryption by default, a ledger for essentially like tracking everything that's happened, advanced auditing features. It has built-in features like column store indexing for compression and performance, in-memory tables, again, advanced performance for really high transaction tables, built-in Entra ID authentication, was Active Directory authentication. This is what a lot of big enterprises use for especially their most critical workloads. It has really advanced high availability, really advanced disaster recovery in the cloud that's built in. And it is some of the most, and that comes at the cost of it being one of the more expensive database services. There's multiple flavors of it. I'm not going to get into this because you don't need to make that decision today, but know that you can do everything from like a group of databases called an instance to just a single database that can be serverless. So it kind of auto turns off, auto scales with heavier workload, and you can even pool resources, which sounds a little silly compared to a managed instance because you're like, wait, it's also a set of databases, slightly different architecture. So there's different flavors of it. What I also love to talk about, though, is why Azure SQL is great for developer teams and app teams. And it's because there's a lot, again, going along with that Formula One pit crew, a lot of extras built in. There are a lot of just built-in native performance tools, like a tool called Query Store, which maintains a history of all of the queries and every time they're run and how many resources they used. So if something was running great yesterday and then not running so fast today, you can just literally go back and look at the two side by side and say, what changed? What's different? Why is it worse? Automatic index tuning, intelligent query processing is a whole bunch of engine features to make things run faster. We have an emulator for local development, so you don't have to go through and like install SQL Server on your workstation to get a copy of the SQL database that might not match up exactly to the engine that's in Azure SQL. You can go into Visual Studio or Visual Studio Code, spin up a container, have the latest code in seconds. It integrates with built-in Azure app development tools like Azure Functions. And we have a tool called Data API Builder that lets you declare, like if you love app development and you do not want to learn all of the fine points of T-SQL, you would just rather do a get or a put and write your SQL code in your app code. We also have access to that through this tool. So that is the beauty of Microsoft's Azure SQL family of products. Again, most expensive, enterprise level security, enterprise level performance features, enterprise level business continuity. So then we have Azure Database for Postgres Flexible Server. And I compare Postgres to the Honda Civic. Postgres, like the Honda Civic, has been around for a long time. Postgres, like the Honda Civic, has tons of different configurations you can do with it through what we call extensions. It is all over the world. It is incredibly reliable. Why is that? So Postgres is an open source database. It has been around for, gosh, I'm going to say 20 plus, probably approaching 30 years as well. And that means anyone can contribute to the Postgres code itself. Anyone can go and write an extension for Postgres and give it some additional functionality, have it checked in, have it reviewed, and be available. With Azure, Microsoft did not take Postgres and say, we're going to make Microsoft Postgres. They used just the full open source community edition in Azure. So yeah, Postgres, #1 database in the world for developers. and that just open source community edition is available in Azure. It supports currently Postgres versions 13 to 18. You configure it using server parameters. You can actually have up to 5 what we call read replicas. So you have like your main database server that your application connects to for writing new data or updating, deleting existing. And then if you have, website needs to serve up a ton of pages, or you have a couple business units that need to report off of the data, you may not want them reading off of the exact same server that all of that writing is happening to. So you can create these replicas that have almost real-time data. And that's available with a couple of clicks or a couple of commands in the Azure portal. I do want to talk about extensions with Postgres. They're kind of what makes Postgres unique and really cool. The Postgres database engine itself has tables, indexes, functions, stored procedures, schemas, like the core things that make data store. With Microsoft SQL Server, every time they want to add a new feature, always on availability groups, query store, spatial data, graph data, whatever it is, they bundled up and packaged it into the database engine itself. It's like the SQL Server download, like if you ever want to download that, is gigantic compared to just the Postgres engine. With Postgres, you install additional extensions that give you extra functionality. There are hundreds of them out there. Some really popular ones are things like Timescale DB, PostGIST for spatial data, pgcron for scheduling, pgstat statements for tracking execution plans, and now Vector, Vector for storing vector data for AI, RAG implementations, that sort of thing. And there's also an extension called PG Bouncer, which handles connection poolings from your apps. And in Azure, that's built in. So again, why are developers interested in Postgres? Number one, the Stack Overflow developer survey that's gone out for the last 6 years, Postgres has been the most widely used SQL database by developers across the world. It's open source. Again, it's infinitely customizable. It's been around for a long time. It's very reliable. It performs very well. There is a query store tool built for Azure Postgres as well. So again, where every execution of a query is tracked over time, along with how long it took, what its query plan looked like. So again, if something ran fine yesterday, you never changed anything in the stored procedure or the function of the app code, and it's not running the same today, you can go and compare those side by side, see where those differences were. Postgres also has that data API builder available, where you can make your tables available, stored procedures, functions available as API calls. So you can just embed that directly in your data or directly into your app code. And Postgres makes Postgres on Azure, makes it really easy to integrate with Azure OpenAI for building AI apps. And then last, MySQL flexible servers. I will compare them to the GeoMetro, which, again, smaller, not as full featured, been around a long time, but definitely has fallen off the radar over the last, I would say, 15 to 20 years. MySQL is another open source database. This is another one that's available in Azure through Microsoft, and it is just, again, the community edition. Microsoft did not take the code, make some changes to it, and brand it as Microsoft MySQL. It's just the community version. Um, I won't go into the history of it too much, but MySQL actually, technically it's owned by the Oracle Corporation now, although they still leave it open source. There is another database based off of MySQL that is truly open source called MariaDB. So if you ever hear of that in your travels through apps and databases, MariaDB is based off MySQL. So again, MySQL has, again, you configure it with various server parameters. MySQL is well known for its ability to replicate data into it and out of it from a lot of different locations. So it has this really consistent, easy to set up, relatively easy to use from, say, a server on premises to a server in the cloud, a server in Azure to a server in AWS, and back and forth. And it supports up to 10 of those read replicas for scaling out reads. And the reason for that is that for a long time, MySQL powered basically the whole internet, content management systems, anything on the LAMP. So the Linux, Apache, MySQL, PHP stack of open source web development. One of my very first consulting jobs was a very small marketing firm. We built websites for companies and everything ran on MySQL. So with developers, right? So if you're going to be doing web development, open source development using a lot of the Apache stack, you'll probably see and use a lot of MySQL. There are different database engines or storage engines available within the database. It has one called InnoDB with clustered tables, clustered indexes, relationships that's very similar to SQL Server and Postgres. It also has a storage engine called Memory, which is in memory tables, and a few other kind of edge cases that I have not personally worked with. It has a tool similar to that query store for the other two called Query Performance Insight, where it will, again, track query execution throughout the database and helping you figure out why it might be slow. And also has access to that data API builder tool like the other databases do. So that's kind of that walk through those relational databases. Again, Microsoft's Azure SQL based on Microsoft SQL Server, the Formula One in that it has all of the bells, all of the whistles, all of the options at the highest cost. Postgres being, again, open source, #1 most used database in the world, tons of flexibility. Almost all server parameters and extensions are supported within Azure. And then MySQL is available, totally open source. Again, used a lot for web apps and a lot of other open source projects. So that's just those relational databases. Now, I also mentioned we want to talk about non-relational databases. You may also hear them called NoSQL. NoSQL is a misnomer because SQL being structured query language, you use SQL to query almost all of these types of databases. So I like to call them non-relational. So when I talk about non-relational databases in Azure, I'm going to reference Microsoft's Cosmos DB. And this I would compare to a Tesla, where a Tesla has an electric engine, right? That's entirely different innards from the internal combustion engines of the other cars we've talked about. Internal combustion engine, electric vehicle, two very different things from relational and non-relational databases. So when you go to create a Cosmos database, it's basically giving you this storage account that's available in every Azure region in the world. And they are connected through the Azure backbone, so they're very low latency to provide really high performance. And they have just different consistency levels. Again, this is another thing I could come in and talk about for a long time, but it's, strong consistency where, only one thread can be writing to this data store, to this document at one time. Everything else has to wait. To eventual consistency. Things write, eventually they converge. You see things. Think about like strong consistency is when you're working with your bank, right? You don't want multiple writes at your bank to collide. You want your paycheck to come in before the debits, before the payments go out. You want your bank account to have strong consistency. Eventual. Yelp or some other review site. Like if you're writing a review for a restaurant and somebody else is writing a review for a restaurant, it's okay, whatever order they show up in. Like typically that's not going to affect the balance of your universe, the restaurant's universe, that sort of thing. So those are the kinds of decisions you make with a non-relational app like that. One of the hard things is that when you go into Cosmos DB, you're going to be presented with 6 different API options, and you're like, what's going on there? Why is Postgres mentioned again? What's happening here? So I'll just give you a quick walk through these. NoSQL is kind of the OG for SQL data for Cosmos DB. This was the original API, and it's document storage. So it just stores everything as JSON. I actually think I have I have a Cosmos DB database up here. I think it has my volcano study data in it. We have some fun data sets available as examples to go play with. A container, yeah, my volcano data. Let's look at our data explorer here so you can kind of see. All right, so when we talk about a document database, we're going to wait for it to load. Authorization header doesn't conform to required format. Okay, well, I was going to show you some of the documents here. They're JSON. Hopefully I'll be able to figure that out before the end of the presentation. But again, that's that flexible schema, right? Where you have like a header called item, and one item is shirt, and one item is phone, and one item is cup. And they all share one common thing, which is color, but one might have a size, and another might have dimensions, and another is how many ounces it holds. Again, you use SQL to query it, so you would still write a select statement. What do people, again, some of the reasons that developers love it. Automatic indexing. You don't have to go through and try to figure out what are the best indexes to support my data. That same data API builder. This keeps showing up here, so it gives you that API where you can just write the calls, again, directly in your app code rather than having to write everything as stored procedures or functions in the database and learn each database's fine query secrets. This also has an offline emulator. So where you're going to see the NoSQL API used most frequently is just about everything. But some of the most common and some things that I have helped customers build them. IoT systems, right? You have a ton of devices in a factory or in even an app, writing a bunch of data in across the world. This available in every region across the world. Any region can be written to. It's eventually consistent, works great for it. Retail, again, product catalogs, website catalogs, really great to use documents for that. And gaming. So you may have like games with different scoring. There's a lot of those use NoSQL databases under the hood to keep track of players, leagues, what scores are at any given time, where divisions might be, that kind of thing. So building on that, you might see an API called or hear about MongoDB. MongoDB is just another document storage type, whereas NoSQL uses JSON, so JavaScript object notation. MongoDB uses its own proprietary BSON or binary JSON format. That's all. So MongoDB is a product that's available, again, on premises in other clouds. Having it in Azure's Cosmos DB means that if you had an existing Mongo database, you could just literally copy that data into a Cosmos DB database, change your connection string, and everything just works. It's the same protocols. Again, for developers, both, let me go back, single and compound indexes, and again, using the same tools that you would for Mongo, like in AWS or in your own data center. There's a tool called Cassandra. This is what we call a wide column data store. Cassandra and other wide column databases are used a lot for logging style applications, telemetry, package tracking, again, IoT, devices that generate a lot of data sequentially and don't really ever need to be updated ever again. That column data store is designed to highly compress and then just not be updated a lot afterwards. There's a table data store, and this is just key value storage. So, user ID location, user ID location, user ID location. Could be, so this is used a lot in just everything. When I think about it, just about any website or app is going to have like a session store, right? So you have your user ID and its session ID, user ID, session ID. Session ID might hold some other details about what products are in your cart or who you were talking to through chat, like that kind of thing. It's a pretty basic store. You don't need complex relationships. So that's what a key value store does, and that's what Cosmos DB's table API does. And then last but not least, I think there's actually one more. There's a tool in there or an API in there called Gremlin. Gremlin is a graph database from Apache. So again, open source tool, the API is put in Cosmos. And graph databases are anything with relationships. Social networks are graph relationships. On LinkedIn, I can be friends with Allie. Allie has worked at CodeU. Ryan was a student at CodeU. Ryan wants to work at Microsoft, right? Like there are these relationships between things, and graph data stores help navigate those things. Yelp, logistics. One of my first exposures to a graph database was the Gremlin API. I'm trying to help a company that did logistics. They were trying to ship things from point A to point B and trying to find the least expensive method to get there. So as you can imagine, think about how to traverse your LinkedIn network or how to get from A to B on Facebook. Similar to that with logistics, right? I have a package. Do I want to take a car to the train station and then put it on a train to get it to the next city over and then have it unloaded again? Or is it faster if I take this and fly it over here because it's a longer distance? What's the trade-offs for that? So graph data stores are really, really cool. They're one that I wish I got to work with more. And Postgres, yes, relational database engine. It has an extension called Citus, which lets it scale out into kind of almost an analytical style workload where you have like a head primary node that scales out to a bunch of workers. And that was folded into the Cosmos DB family for its replicated storage. In the end, still a relational database. So that's the very quick walk through the different kind of Cosmos DB APIs that you could see in Azure. All right. I mentioned there's in-memory databases. I will talk about this very briefly because there's one, and it is Azure Managed Redis. And whereas we've had internal combustion engines and we've had our electric vehicles, I would compare Azure Managed Redis to a Ducati or another type of very fast motorcycle. These are data stores that live entirely in memory. So they are very fast, right? But because they're in memory, they typically have slightly smaller database sizes, right? You might be able to get 128 terabytes of memory on a given server, but you're probably not going to, without spending an obscene amount of money, get 2 petabytes of, or even 2 terabytes or 2 petabytes of memory on a server. So Redis and other in-memory databases are usually designed to help with your data caching, your content caching, your session stores, any data that you need access to very frequently and very quickly. Again, they integrate with some of Azure's built-in app tools like Azure Functions. Probably 2 biggest things, storing data that doesn't change very frequently, or storing like static web content, images, tables, that sort of thing. All right. So that was a quick walk. It was about as quick as I can do walking through all of my the just transactional databases available to us. And when this is kind of where I was going is, again, we're talking about platform as a service. So managed. So I made this nice table. I think it's nice. You can give me your feedback. But this kind of shows like when we talk about managed databases, when we talk about those platform as a service offerings, what is managed or included for all of these across these Azure databases? So there's backups, right? Taking a backup of a database, bare minimum requirement for business continuity and being a DBA. All of them have automatic backups. Your database backups are only as good as your ability to restore them to a point in time. So all of these databases also give you the ability to just say, I would like to restore my Postgres database called cars to Sunday, November 30th, 8 p.m. before we rolled out that app change that wrecked some things. I list geo restore here, meaning that you can store your backups in a different Azure region. And thus, if like a whole region goes out, you could go up to its backup region and just pull your backup out and then have some basic disaster recovery. You'll see high availability within the same region for Azure SQL database and Cosmos DB. That's automatic for Postgres and MySQL and Redis. It's available. So all of these things are built in. Disaster recovery, so to a different Azure region. Again, all of these are available and managed for you. And even some of those, again, all operating system upgrades managed, all hardware upgrades managed. Some of the actual database engine upgrades are managed through all of these services as well. And as I talked about, a lot of them include tools like automatic indexing, query stores, or other query tools to track query performance over time. And so that's the benefit of a platform as a service offering. You get a lot of this management work done for you at a slightly higher cost. And so when you're building your apps and choosing your databases, again, you'll have to make that decision between IaaS, infrastructure as a service, getting the most control and having to make all the decisions and do all of the maintenance versus having these database engines available for you in a managed platform. So I hope this someday can help you, kind of weigh those options and decide. If you are looking to try any of this out, there is an Azure free account. It says free. You have to enter a credit card. You get $200 in the first 30 days. Make sure you put a reminder on your calendar to cancel it after that. But all of them include, or I'd say it includes access to all of these different databases. You can find sample code on Microsoft's GitHub. We have a ton of documentation out there with different quick starts and templates and samples as well. And so again, with that, I will leave up my contact slide and I will open the floor for questions. I think we have a few minutes, Allie. I talked a little fast in a couple slides, just so I could leave some time.
Yeah, no, that's great. And sometimes we go a little past 7, so it's no worries at
Okay.
all. Yeah, you're totally fine. But yeah, if anybody has any questions, I don't see any in the chat, but please feel free to come off mute. We for some reason have someone's joining. But yeah, feel free to come off mute if you have any questions for Jes. I will actually gonna go ahead and stop recording here. Because it'll yell at me for ending the call eventually.